Hello, everyone. This is Michael Hicks with MBA 602. We are going to start today working through supply and demand models. These are the working blocks of most basic microeconomic models and form like the last example that we had, a production possibility frontier, introduced something new to our analysis. The PPF, the production possibility frontier, was a two good world with a command economy, not markets, that illustrated production technology constraints upon the total volume of goods or services that could be provided. And what we're doing here is looking at individual goods or services, and we're introducing price and quantity in a market. And we're going to begin by saying there are two sets of actors. There are producers or suppliers and consumers, or those who buy goods, and they interact in a market. And we're going to begin by saying we're going to draw, as we did in the earlier example, we're going to have a vertical axis. And on this, instead of having a good, we're going to have a price. And then we're going to have a horizontal axis that is going to have a quantity of the good produced. We're going to begin by thinking about the demand for these services and how we describe this in economics. We think in the textbook and any other textbook that you have in economics will say that demand is the interaction of price and quantity with respect to the way consumers look at it. So the law of demand says that as the price declines, as the price goes down, the amount of the good produced will increase, so that the demand curve will look like this. We'll label this the demand curve. But we know that price alone is not a variable in consumption. That's determined by the interaction supply and demand. What really determines then demand, where demand is in space, are going to be other variables. And these include the number of buyers or sellers within a particular market. And in our examples here, don't get too wrapped up in what I mean by market. We'll get to that later on when we get to antitrust definition. We'll understand how difficult it is to describe what a market actually is in terms of defining it. So, for example, the market for lifeguards in Muncie, Indiana is pretty small. There's 2 or 3 pools. There's teenagers who can be lifeguards. The market for finance professors is a global market. So both may take place here in Muncie with the finance department, but if there's a help wanted ad for a finance professor, they'll probably get 500 applications from around the country. If there's a help wanted ad for a lifeguard, they'll probably get a few dozen from Muncie. So there's a geographical aspect and other issues involved in it. But the number of buyers in a market is going to determine the demand for a good, their income, their tastes or preferences. Those are 3 things: number of buyers, their income, their taste or preferences, and then the price of related goods. And there's 2 types of related goods. There are related goods that are complements that we consume together. Tires on an automobile, pizza and beer, we consume these things together, or things that are substitutes. So an automobile and a bicycle, a glass of beer, a glass of wine might be substitutes. And so the price of complements and substitutes have differential effect on demand. And then consumer expectations about the future, which we normally don't talk about. And so the way demand works is the law of demand is illustrated by this downward sloping demand curve. But and here's the first example of why statistical analysis is so helpful. This is 2-dimension world, price and quantity. And if I were a sophisticated drawer, I could draw a 3rd dimension. I'll actually demonstrate my ability to do that later on in the class. It could be time or it could be income. But I've just described a world that is in price dimension, quantity dimension, income dimension, number of buyers dimension, an infinite number of dimensions of the price of related goods, and consumers' expectations. So that is a n, or a very large number of dimensions, which I can't draw. And so the convention in economics has been, instead of drawing these different dimensions, what we'll do is we'll put price and quantity on a piece of paper and then describe all the other dimensions by a shift in the demand curve from D to D prime. And this is called a rightward shift of the demand curve. Right, and this would be caused by an increase in incomes, an increase in the number of buyers, a reduction in the price of a complementary good, an increase in the price of a substitute, or by consumer expectations of higher prices for the product in the future, or an increase in the tastes or preferences for that product. A leftward shift, so this is called an increase in demand. If we move along the demand curve, that's just called a change in quantity demand. And you'll see when we introduce the supply curve that there's a purpose and a real effect of that distinction. Here we have a demand curve that we'll call this double prime. A decrease or a leftward shift in the demand curve. This would happen from a decrease in the number of buyers, a reduction in income, a reduction in the taste or preferences for that product, an increase in the price of a complementary good, a reduction in the price of a substitute, or a consumer's expectations that there'll be a future price drop for this product. So this is the law of demand, and we want to be very important. It's possible, I'm going to introduce supply in just a minute, but we have a demand curve here with the law of demand. We have these 5 separate features that affect the demand curve. And so we're drawing this demand curve in space where we have y is equal to alpha plus beta x. That's our linear model. In this case, price is equal to alpha plus beta q, right? And the slope of the demand curve is that beta value, okay? And by introducing those other 5 values, we would also then have 5 other coefficients. We'd have beta 1q plus beta 2 would be the population number of consumers, right? And we can go on and on and on with each of those. And I'll show you a demand curve. That's what we're going to statistically estimate in the next week or so, and that'll be your first practical example along with the other material that I'll pass out. Now, what's important with this demand curve, keep this in your mind, is the law of demand has the demand curve always sloping downward. We have these 5 factors that influence demand, but you can move up or down the demand curve because of some other feature. And that other feature is going to be supply. So we're going to save this. I'm just going to open a new example here. And the demand curve gives us the fundamentals of what we observe. It gives us the behavior of consumers, at least a framework to think about the behavior of consumers. The demand curve is actually built up from an individual model of households and their expenditure function when they're maximizing utility. So whenever economists use supply and demand models, we're thinking about more fundamental household behavior. And that comes through in the demand curve. We also think of more sophisticated supply side features, right? We have the same domains here. We have quantity and we have price, and we have the law of supply that says as prices rise, more of the product will be produced. That gives us a supply curve. Then we say the supply curve is affected by four things. It is affected by the number of sellers, the input costs, how much labor costs or how much material costs, the available technology to produce, or the expectations of producers. And so let's go through these. If there are more producers, there'd be more of the product. If there's less, there'd be less of the product produced. If there is a increase in the input cost, petroleum costs or labor costs or raw steel costs, that will cause the supply to be reduced. The reverse is also true. If labor costs drop, if the number of the input costs for metals or petroleum drop, then the supply will increase. Then we have technology. As technology increases, there will be more of the goods supplied. As technology decreases, there'll be less. And then finally, the expectations of sellers also matters. As sellers think the price is going to go up, they're going to hold off producing and selling it today. If they expect the price to drop, they'll want to sell it as soon as they can. And so the supply curve can shift from S to S prime with any of those factors. And recall, if it's just price or quantity changing, that's a movement along the supply curve. If it is one of those other four factors changing, then it's a movement of the supply curve. And it's that straightforward and that simple. So that gives us the framework for thinking about this. And we also have another linear model here where price is equal to, we'll call it A plus gamma Q. Okay, so that's a linear function. So the market exists when there's an interaction between the consumer who demands the product and the producer who supplies the product. So let's see what that looks like and how to think about it. We start with the same formulation. We have a price we have a quantity, and we have a downward sloping demand curve that obeys the law of demand, and an upward sloping supply curve that obeys the law of supply. And so these graphically depict the consumer behavior along where we have consumers that as the price is high, very little of the product is bought. As the price drops, they're willing to buy more of the product. That's the law of demand. And we hold in this graphic all other things equal. So there, at this point, there's no changing, in the number of the consumers. There's no change in incomes. There's no change in the price of related goods. There's no change in consumer expectations. No change in taste or preferences. Same thing with the supply curve, except the supply curve is the opposite. It says that as the price rises, there'll be more of the goods supplied. And we're saying that all things are being held equal here, that there's no ongoing change in the number of sellers, there's no change in the input costs or technology or expectations of suppliers. Of course, that's a rare condition that's rarely met. The world is full of change, but when that happens, we have what's known as market equilibrium. Market equilibrium is the interaction or the equality of supply and demand. We'll call this P star. And we'll call this Q star. So the interaction of the behavior of consumers that are captured by the market demand curve and the individual behavior of suppliers that are captured along the supply curve yield the price of the good and the quantity of the good produced. That's basic supply and demand model. Now, students have a couple of conceptual problems with this. All of us are consumers. We understand the demand curve. We understand that if our incomes go up, we're going to buy more of most goods. There are exceptions. We'll talk about that a little bit. We know that as our tastes and preferences shift, we're going to demand more of a particular product, or the price of related goods changes that will change our consumption of the product, our demand for the product. And so we understand that. And suppliers, we're all suppliers of something, but maybe it's just labor. So that's often a little bit more difficult for people to picture. And it's important not that what's good about this is not its complexity. In fact, this is an astonishingly simple model. It's actually mathematics. It just brings into equilibrium or the equality these two equations where price is on the left-hand side and quantity on the right-hand side. We take these, there's two equations and two unknowns, and so we solve for them. So there's your 8th grade or 7th grade Algebra 1 problem of solving for using two equations, a supply and demand equation, to solve for two unknowns, price and quantity. And that's simply all we do. Now, in the statistical work that I've described, we used the plots of a linear regression to describe a line. Well, imagine that we could do that here as well. We can describe a supply curve based on the observation of sellers. We go out in the real world and count the price and quantity of the good produced. And it's just, we could call it pizza, we could call it gasoline, it doesn't matter. And the same thing is true of demand. We could at any time and place measure demand, parts of demand, by trying to draw a line here. The problem is that what we observe is not the theoretical supply or demand curve. What we observe are just a series of equilibrium points when there's changes. So we know that all the time tastes and preferences are changing, right? Or incomes or the number of buyers are changing. So all three of those would cause the demand, if they're an increase, the demand to rise, right? So we're also interested not just in determining the price and quantity of a good, but what would be the effect of a shock to the system, a change in the number of buyers. So there's an increase in the number of buyers, what happens? Well, we know that that's a demand side effect, not a supply side effect. So we see a shift along the supply curve, which is called a change in quantity supplied. And then we get a new equilibrium price at the new demand curve, its intersection with the supply curve. And we get a new quantity here, right? Call that Q prime and P prime. And so that's the result of a supply curve shifting. Now I'm going to stop lecturing here. And introduce 2 or 3 guest lectures, which I think I do a good job with this. I'll pick this back up, and in the next class, I'll show you how we can do some estimating of a demand curve in using statistics. And with that, thank you.